All right. Hello, welcome everyone to this demo session. We are presenting cadCAD GPT, the LLM framework to support token system simulations. Great to have everybody here. Great you are interested, and I think we have something really exciting to share. Let's kick it off. Let me find my slides. Here we go. cadCAD or cadCAD GPT. This is the team behind it. It's me, myself, and my colleague, Rohan Mehta. He'll take over the second part, and then I guess you can introduce yourself as well. I'm founder of TE Academy, and back in April, we were thinking of, oh my God, LLMs could be so exciting to help us handle complex systems, to help us run simulations. Let's explore. And we have been very lucky to have great partners here and allies. First of all, TE Commons, who kickstarted this project with funding. Thanks to Gideon, who's in the call as well, who got me basically excited about this idea and supported us in the initial phase. Then we also would like to thank Roderick, Richard, and Robert Koschik from 1KX, who have been great advisors and are still great advisors in this journey. Achim Struve, Dimi from Outlier Ventures, Stephanie Tranicek, Ivan, Rohan, and Lukasz, who have been providing us feedback as alpha users. And last but not least, Caitlin, supporting us in all the writing efforts. So we wouldn't be here without you. Thank you so much for your support. Talking about support, 1 week is left. We have an active grant application at the Optimism retroactive grants funding. This is really important. This matters. Let's fund public goods education as we provided with TE Academy and open source tools like cadCAD GPT. So in case you are a voting badge holder at Optimism, or you know someone, ping this person, please ask them to support us. The grant application is behind the QR code. It really matters. Thanks for your support. Okay, now our agenda today. First, I'd like to introduce you to the conceptual framework of cadCAD GPT and also the requirements we've put together to give you a first context. Then Rohan will walk you through the GitHub repository. So today we are open sourcing cadCAD GPT, meaning it's available for you guys to start testing it, to apply it to your own projects, and of course, to collaborate with us in further expanding it. And then we close with an outlook and contribution opportunities, and also a wider perspective on how tools like this can further develop the token engineering discipline and sector. Okay, let's start with the requirements. So what do we want to achieve with LLMs? Large language models that basically are not built for running simulations. I mean, it's first of all, a natural language interface. And this is obviously something we'd like to apply to token engineering. So yes, we'd like to have a natural language interface, but mathematical, I mean, running simulations, math is not intrinsically or an intrinsic capacity of LLMs. Still, on our list of requirements for cadCAD GPT is we'd like the agents to be able to access, modify, and run Python token system models, with Python as being the main language for token engineers. And we'd like them to provide further analysis of simulations outputs. Okay. Third requirement is we'd like these agents to be able to access and integrate data and information. Think of transaction data, historical data, other behavioral analytics, or even types and patterns of behavior, fundraising data, market data about tokens, etc. Fourth requirement, we'd like these agents to select the best method to be applied in a simulations process and the right ordering of methods. Think of your own process in token engineering, or if you're interacting with systems, it's not only about the method itself, it's also about when to do what in what ordering. And this is something the agents have to understand. And last but not least, we'd like to not just get any result or any kind answer from an LLM agent. Instead, these results that the agents provide us must be correct, mathematically correct, verifiable, and reproducible. So this is our list of requirements for cadCAD GPT, and we've met all of them. And I'll show you now how. So this is the general framework. In the center, we have the cadCAD GPT chatbot, which is basically this large language or this natural language interface, and it's equipped with two key agents, the planner agent and the executor agent. The planner agent takes in the user input, so your question in natural language, so no code, no particular prompt design, it can handle natural language, and then the planner agent takes over and designs or derives a plan, step-by-step task list that is then taken by the executor agent. And this executor agent is able to select the right tool that we see at the bottom, the toolkit, and memory needed to complete these tasks on the task list. Memory is on top, and we get to this in a moment. So we have two agents that support this process, and these are the key, this is the key intelligence in our chatbot, the planner agent and the executor agent, and both submit their results, so meaning the task list, the results of the individual sub-steps, the tools and memories in use as part of the user output that makes it then overall verifiable, auditable for the token engineers interacting with the cadCAD GPT chatbot. All right. Now let's take a closer look to the agents and also to the toolkit and the chatbot. So we see, again, we start in the center on the left, user input, natural language, planner agent, plan steps, describes the tasks. We'll see later how this works, provides the tools and the context, meaning it starts creating a list of steps and recommendations of tools to use for the executor agents. And then this task list is handed over to the executor agent that reasons then about the process and about the task to be accomplished, selects actions, also shares observations, and prioritizes and reprioritizes the tasks. And then this output is taken and submitted as an output to the user, again, to make this process verifiable, and is then provided as an output. Give me a second, I'm back to the presentation. Okay, can you see it again? All right.
Yes.
Good. Now let's take a look at the toolkit. The toolkit is what we provide the agents to use, because again, LLMs are not built for using or producing Python code. Instead, we provide them with tools. And today we had 5 tools in the toolkit. Now today we have even more. Rohan was pushing hard over the last couple of days and has added some additional tools in the toolkit. The core message here is these are Python functions, and it's expandable. And of course, every project might need some very particular functions and methods to approach a certain token engineering challenge. And you can add these tools to the toolkit. There are some requirements, but it's really easy and very convenient to add your own customized tools to this toolkit, make it accessible to the LLM agents, and this way customize it to your own project. Plus, hopefully, open source them to some extent and make it accessible for the community. And on top, we see the memory section. And this memory section gives some examples of what is memory. There are more details in the articles we've created on Miro. You'll find all the links in the GitHub repository that we'll share today. But just briefly, we can process model documentation. We put it in a vector database to make it accessible and searchable for the LLM agents. We also can use and build on simulation output, meaning prior runs of the simulations or prior experiments. Plus we have, as we call it, short-term memory, the message history that also helps the agents to better understand your questions, which is added and provided to the agent as chat content. This is limited in terms of the volume, but LLM agents are making fast progress. There are some tweaks here. We'll get to this in a moment. But again, also the memory section, or what we provide our LLM agents as memory, is expandable. So whatever you have as a simulation project, you can customize and add particular knowledge that you'd like to make available to the agents via the memories. Okay. Now, before we dig into the repository, I'd like to say some words about the token engineering stack to frame this in the right way. As a token engineer, your key area of expertise is building a model of the token system, either because you are designing it from zero, so there's nothing there, no existing model, or because you need a particular version, you'd like to address a particular question, meaning we always need a representation of the actual real world system. So we are building a digital twin in Python, the system model, and then on top of it, we apply optimization techniques to tackle a certain question, to get to a certain design, verify a certain design, or optimize a certain parameter setting. And there we apply A/B testing, or we run sensitivity analysis, or we apply simulated annealing, whatever methods, and many times it's a whole set of methods to get to a certain result. Meaning our core, we are interacting continuously with a Python model, and whenever we have new questions, so we provide a certain simulation output, discussing with the stakeholders, new questions pop up, we have to adapt the system model or change parameters. And this, of course, takes a lot of time. Now, the core idea of cadCAD GPT is to provide a new type of interface that achieves two goals. It's way easier and faster to interact and adapt your model because, again, you can access the model, you can change the model, you can run certain tools, methods to get to a certain result, all not via coding, rather via interacting with your LLM agents. And second, these optimization techniques can be stored or made accessible via this expandable toolkit and memory features. And this makes it quite modular. So the cadCAD GPT is able to interact with any cadCAD or RadCAD system model. And in fact, it could interact with any type of Python model. And this overall provides the potential that teams plug and play methods to models easily, or that even a range of collaborators contributes to optimization techniques and to simulation runs and experiments on a certain token design. All right. I hope this was a good and easy introduction to the whole concept of cadCAD GPT. And I'll now hand over to Rohan to walk you through the open source repository.
Yeah, okay. I'm sharing my screen. Can you guys see it?
Yeah.
All right. So hi guys, I'm Rohan, and I'm the data scientist on this project. Basically, what you're seeing right now is the GitHub link to cadCAD GPT, and I just scroll down, like apart from the introductions, when you reach the installation section, this is basically where I'm gonna take y'all. So this is how you can get it in your own system. And another way to just do it would be just like, download the zip file and start running it. Mainly, actually, the entire project itself is in this folder called cadCAD GPT. So all the agents, the memories, the tools, everything that Angela spoke about, the way it was in the diagram is broken down that way in the code itself. But what I'm going to show you all is in the example section. I'll go through a predator-prey simulation. By the way, this cadCAD GPT runs on currently on any radCAD model that you have. We are still moving into cadCAD. It's not that much of a transition, but currently radCAD is the one that works the best for us. So there's a template project here. So you can, when you open the template project, this is the structure in which if you ever have your own radCAD code, you can just place it in this example radCAD file. And all the instructions are there in the GitHub README. But once you put your code here, just replace it here. You can jump into the example project IPNB, and this is where you can start chatting with your like cadCAD GPT chatbot. I can actually, the same thing that you're seeing here is what you're going to see in my code, in my VS code. Am I sharing the right screen? The ID?
This is the predator prey.
Yeah, okay, cool. So if you look here, it's the same exact folder structure, but it's black now. And the entire cadCAD GPT is here. The examples are where we are going to go. So we are going to look into the predator prey example. All the code for the predator prey example has been taken from Danilo. So radCAD, the project itself on GitHub, has their own example folder, and they have a bunch of like predator prey examples, a bunch of like simple examples to show how to run radCAD. I've just taken one of them, and this is all the code that basically runs your radCAD simulation of predator prey. What you actually need for the cadCAD GPT to work is only three things from your radCAD simulation, which is the model object, the simulation object, and the experiment object. That's all you need. And every time you run a cadCAD or a radCAD simulation, like when you build your model, these three objects will be always available to you. So that's the preface. All we do is we import all of those three objects from your radCAD file itself, and you can start chatting with your cadCAD GPT. The way you do it is you place your OpenAI key. In my case, I didn't want to show you all, so I already ran it. And and you basically, this is the part where it starts. Since the cadCAD GPT folder is in the predator prey folder for me out here, I can directly just import it from cadCAD GPT. I import the cadCAD GPT like class. And in order to instantiate it, in order to create a instance of a cadCAD GPT chatbot, you need to give it your OpenAI key, the model object, simulation object, experimental object, and docs in case you have them. This is completely additional, but I think the value add is quite interesting, and I wanted to just show what we can do with this. So the value add of the docs folder is the first thing that I'm showing you. What you're seeing, I hope my screen size is okay. Can you all see the text, or should I zoom in a little? Maybe.
Looks good to me.
Okay, good.
I hope everybody can read it. Yeah.
Yeah. So what's happening here is we created the cadCAD GPT chatbot just by running this file, like running this code, and now you have this chatbot that you can start like asking questions to. What you have here in orange is the question. Is that orange? I think it's orange. Is the question that you're asking to the chatbot, And the output here is what you see, the agents talking to each other, trying to solve the problem. And the final answer itself is in yellow at the end. So we asked a question, what is the model about? And the planner agent, if you see what it went through, is it made a plan to follow. It understood that, okay, based on this question, given the tools that I have access to, I should be using, like my step one should be using this particular tool, which is the function, and to fetch information about what the model is about. It passes that information to the executor agent, which goes through a bunch of steps. Currently, we don't need to go too deep into it. The core of it is that the planner agent decides the tool to use. The executor agent decides what information to give to that tool, and then observes the result that comes out of it. And the result here is the model is about predator-prey simulation, which models the interaction between population of prey and population of predators. This information actually isn't something it came up with itself. It's a document folder that we've given it out here, Markdown. So if you see on the side that we've built a document that explains where we got the code from, what parameters we use in order to run the simulation, the states of the system, the everything, just all the information. And this is good practice whenever you're making a simulation or a model for anything. Like it's good to have a document that explains the assumptions, limitations, and stuff like that. If you have that, you can give it to cadCAD GPT in the docs, and you can start chatting with it, and that's how the information is coming. So cadCAD GPT is intellectually is using the long-term memory function in order to fetch, store the data in a vector database, and then fetch the relevant information to answer the question you need. This is the same thing. How is the pre-population calculated? All of this was there in the documents. It's able to fetch the right information. It's calculated based on blah, 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 whatever the information was. So all you need to care about is what's happening here and what's happening at the end, because this is the question you ask and this is the answer you get. We can actually do many more things. So apart from just accessing and chatting with your docs, which is pretty standard, what you can start doing is now you can start interacting with your Python code itself. And the way you do it is you ask a particular question about the model. Our planner agent understands what that means and which function to use to fetch that information. And it passes that information to the executor agent that, hey, I need to use the model info function. These are the parameters I need to send to it, and it fetches back the result. This result itself, and I'll go deeper into the tool Python file, the toolkit, but it's just a standard Python code that's actually running in the backend. And this gives us access to both the orchestration and the contextual thinking ability of language models with the accuracy of software. And what's happening, as you can see, you can pretty much do you can add any tools. The tools that I've added here is for plotting. You can say what plot you want, and it understands which function to use. Again, figures out what request to send to it, and it builds a Plotly express plot for you. There's a population of prey and there's a population of predators. You can ask, it's not just line charts, you can actually just say, you can just describe the kind of plot you want and it'll build a phase diagram for you. This is again very, in complex systems modeling or even chaos theory, like in those fields, it's very standard to have this phase diagram or a state diagram kind of visualization in order to see how the state evolves over time. So you can just ask that question, can you plot the prey population against predator population as a phase diagram? And it understood it, figured out, did it for you. These are all, again, what I'm showing you all currently are just a single tool is being used. And what we'll move to as we go ahead is you can ask multi-hop questions, and which is where the power of this framework actually starts showing. One of them, and there's a nuance here, and if you guys want to stop me, please do. If you ask a question about the statistics of your data frame, like whatever the model has come out as a result, what happens is the planner agent makes a plan, says that, hey, we should pass this to the analysis agent. Now, some tools are not just Python functions, they are agents themselves. And they're specialized agents with the ability to, with the domain expertise of, let's say in this case, doing statistics on your data frame. So it's a pandas agent for Python. and it's able to, it's actually running on the Python backend, the actual query. For example, we asked, what is the average value of a particular column? It understood which column, it understood the exact variable to put into it, and also understood that it has to find the mean, and gives an answer, and the final answer is the average predator population is whatever, like 181. But you can go even deeper. You can ask descriptive stats, and the final answer, like, yeah, again, the same thing's happening. It figures out which function to use. The executor agent goes in. The analysis agent now actually runs the Python queries in the backend and gives you the answer of the mean, median, standard deviation, percentiles, meet everything. This is where it's like the framework actually starts shining. It's super interesting, where you can ask multi-hop questions, where what you're doing is you're chaining questions together, because in a lot of it would be pretty useless to have like a chatbot that just gives one answer at a time. But if you can give a chain of questions and you say that, hey, what is my current prey reproduction rate? Can you triple it? Can you plot the population, and then give me some statistics? You could like ask something like that. In this case, we just did three. It again broke it down into 3 steps, figured out which functions to use, gave you all the answers one step at a time, and also plotted the final diagram. And you can see that we actually changed the prey reproduction rate to some other value from 0.6 to 1.8, and you actually see that this completely makes both the populations go extinct. So this is actually changing the code in the backend. It's changing the simulation parameters, and it's running it and then plotting it for you. So the beauty of this entire framework is, again, like all the complexity of running Python, of understanding which tools to use, when to use them, all of that is now like, it's abstracted away, and you just need to say in English what you want, and cadCAD GPT can convert it into code for you. Yeah, I mean, like, this is a line chart again, like same thing. You can arbitrarily like have pretty long chains. I've actually not pushed into the limits of how many I can do, but I think at 5, 6, 7 steps, it's able to handle, where you can ask again, like all the functions one by one being used in different orders. The thing about this entire setup is that if you read the articles, you know that these agents also have short-term memory. Currently, only executor agent has short-term memory. What that basically means is that it has a brief like memory of all the conversations you've had with it within the chat itself. So if it needs to use any particular result from a tool that it already executed on, it has a memory, and it is able to access that, be able to use it, and then run the code again. So that's why you can ask questions like, hey, what's the current value? Can you double it? Can you half it? Like you can reference your previous tool observations and get your results out. Yeah, and then yeah, I mean, like, this is the same stuff. I've just like shown that you can pretty much like chain any kind of questions with the tools that you have. I can, if y'all have any questions, y'all can pause me here, but I would like to go deeper into basically what these agents actually are, how are they actually functioning, and what the tools actually are. So if there are any questions, like, you can pause me and let me know. What is an idea of the cost for this for a given project? So I mean, I've been running this because we're using GPT 3.5 for most things, it's like extremely cheap. I mean, to the point that I maybe in a month where I'm using this pretty heavily, I'm maybe spending $3 to $6 at best. I don't think I've spent more than that on this project. And uh, if you want more accuracy or you want to do complex problems, you can switch to GPT-4, which I've done for some of the tools currently. That's like 10x more expensive, but even that is only for certain aspects of your code. So I don't think you ever cross like more than $10. Even, I mean, like, depending on how much you use it, but it's like pretty minimal. What are the next steps? Yeah. Actually, maybe I can show you all the tool, like how the tools are, like what the tools actually are, because I think that will give everybody an idea, especially the people who are developers here, about how to build your own tools. Tools actually, at the end of the day, if you see here, are literally just Python functions. Like that's just a very standard Python function, which has a name. It has like the input variables, the output variables, like, I mean, a return statement. So it's a standard function with some logic stuff inside. And this is a doc string. Again, like developers will know, like you're just explaining. Generally, when we write doc strings, it's for other developers to understand what that function is for. But in our case, these doc strings are super relevant, not for other developers, but for OpenAI itself, like because we are using GPT 3.5. So before the code runs, when you're initiating the cadCAD GPT chatbot, this is what your planner agent and executor agent know about your tool. They are not actually running Python on the backend. They are not doing anything with the software. All they are doing is brainstorming which tools to use when. All they are doing is orchestrating and planning. And the way they plan is through the knowledge of what these tools actually do, which is in the doc strings itself. So in the change param function, I've said changes the parameter of the cadCAD simulation and runs the simulation to update the data frame. I've just literally explained what the function does, and it understands when to use it. The planner agent understands when to use it just based on this doc string. A little bit like you can tell you need to say the arguments and the what do you say, the data types, because in order to get the right, in order to run the Python function in the right way, you need to clarify what the data types are for your arguments. I think I have a question. There's a question. Did you try other LLMs besides OpenAI? A good question. We haven't actually, because GPT 3.5 Turbo, and especially there were some versions of GPT which are fine-tuned for calling for function calling, and that's what we've used. So OpenAI function calling is what we've used. It really improved our performance in terms of being able to get actual JSON output that we can run on Python itself. So currently, I haven't found any LLMs that are this reliable for function calling, but I'm sure pretty soon we'll have fine-tuned LLMs that will do it. What is the orchestrator? Is it like AutoGen? No, it's the orchestrator. When I'm saying orchestrator, it's just actually it's the it handles the conversations between agents, when they should talk, at what point should they talk, what information should they pass to each other. That's what I'm, I guess, referring to as an orchestrator. You can find it in the cadCAD GPT.py file, the entire logic of how everything's happening. And the agents themselves, by the way, so we've gone through tools. Tools are just functions. You can build your own functions very quickly. I can show you the ones I'm actually building currently for parameter sweeps, for Monte Carlo runs, for A/B testing. We are building functions that will make it super easy for people just to describe the kind of experiments they want to run in English, and cadCAD GPT will run it for you. But the way the agents are actually functioning, if you see, the agent itself is just an OpenAI wrapper. That's all it is. It's a well structured prompt with a bunch of examples about how to, like, when a question is given to it, like for example, if the user says what is the current value of XYZ, it has, I get it to reason about what it first initially reasons about what functions to use and when to use it, and then gives you a parsable, like what do you say, the output that you can now use to actually print your stuff. That's basically what's happening. So it's just a very well-designed prompt. That's planner agent. Executor agent actually is a little more complex. I mean, it's a function calling a function calling prompt. So it's basically, it's designed to know what functions that it has and how to actually send arguments to it. But yeah, all the code is available. This is how we are actually handling the short-term memory by adding and deleting messages. The reason we don't litter it with all the messages is because, again, we wanted to focus on the context of the conversation. So if you're a developer, you can play around with all of this. If you understand what it's doing, you can play around with it. You can decide how much context length it should have, how much memory it should store. All of these things can be played around with. You can play around with even the memory section, like the long-term memory section, better retrieval techniques, better tool usage. All of this is open and available. So in this case, I am using GPT-4 Turbo, way faster than GPT-4 and way, I think 1/3 as cheap, I think, at this point. Also, yeah, I wanted to just give you a sneak peek of the stuff I was building, which is in the Scratchpad section. I don't know if I think I pushed it to the GitHub, but it's the A/B testing tool, which actually you give it parameters. You say that, hey, would this be better for my metric, or would this be better? And it actually runs the test for you and gives you an answer in something like, like the first parameter setting was the better one. You can even actually wrap machine learning functions into these tools. So you can actually do really complex optimization techniques and stuff like that. Because I mean, at the end of the day, it's a Python function. You can make it do anything you want. Parameter sweep is also something I'm building. It's built, but I need to like get the agents to use it. Yeah, it actually runs all the code and gives you an answer at the end. Yeah, I mean, I think I'm pretty much done with most of the things I wanted to show. If there's any questions, I can.
Yeah, Rohan, we have some questions in the chat. I just pick, forgive us if we're missing something. I'd like to pick Alex Sarember's questions. Maybe you take a look or I read it out. The first one is, did you notice that there are some types of tweaks that you were making that were recurrent?
Did I notice that tweaks that I was making? That do you mean in the prompts? So I would say like in prompts, I've actually pretty much nailed. I mean, as far as I know, I've nailed how to get it done. Like you first explain to it what the role of the agent is. You give it like what your job is to do. You give it a methodology about how to reason about the task. The reason we are doing this is because again, I don't know how deep we want to go, but like language models are auto-regressive. Like I mean, like they keep calling themselves and they just guess the next token. So the more tokens you make it generate, the better output you kind of get at the end, as long as like I mean they're generating the right tokens. And few shot prompting is the best technique I've found so far to get it to do what you want it to do in the way you want it to do it. So you just give it like a bunch of examples and it understands the pattern and it follows that pattern for unknown questions too. So we need to build a model separately before we can use this tool. Yes, you always need to build a model separately. We are currently not letting, we tried using LLMs to build some models here and there, but at the end of the day, we realized you need the expertise of a human to understand the parameter settings and assumptions and limitations, and you can't let a language model take those complicated decisions yet. Yeah, so those are the agents that we have. These are the tools, all the information. Basically, if you see the cadCAD GPT folder, it's there inside. So this is the main one. You can copy whenever you need to create your own project. All you need to do is open the template project. There's a cadCAD GPT folder available there already. Either you can start coding here by just pasting your radcad code here in the radcad.py and then start playing around with it in the ipynb file. But if not, then you can just copy this folder and take it to wherever your project is in the world, like in any folder in any whatever repository, and it'll work as long as you have the dependencies installed, which you can do through the requirements page.
I wonder, Rohan, should we just ask some questions?
Yes.
Yeah, let's ask our agent some questions.
Okay, I played around. Oh yeah, I didn't do that. Oh, I completely
forgot.
Okay. So yeah, I mean, y'all can, if y'all have any questions that y'all want to ask cadCAD GPT, if you want to print, if you want to plot something, let's try plotting a bar chart. I mean, I've never tried a pie chart. So plot a pie chart of the, wait, no, how would we do? Okay, plot a bar chart of the minimum values of the 3 and theta columns. I don't know if this will work. Let's see. Yeah, so it takes about like 10, 12 seconds, depending on the tool it's using. It might take some time because some tools themselves are calls to OpenAI. But yeah, so first, so based on what we asked, plot a bar chart of the minimum values of predator and prey columns. It first understood that it needs to find the minimum values, and then it needs to create a bar chart. Did I say bar chart? Yeah. Let's see if this works. Okay, not bad. So yeah, it found the ugly chart, but it did find the minimum values and plotted both of them. So it's interesting that in this case, I actually didn't even indicate to it how to use the tools in what order. I didn't like say it in that order, but it figured it out itself. It just understood to find the minimum first and bar chart next. How much time do you need to implement a tool? Depending on how much time it takes for you to write a Python function. That's it. I don't think it's more than that. Um, yeah, if you have any other questions, maybe like we can rerun some of the other queries to see how much time it takes. Because so like this was a long one. Yeah, this one maybe. Sometimes I would say it's still unstable because we're using LangChain in some of the outputs here and there, and because OpenAI keeps adding stuff, LangChain keeps adding stuff. Some things break here and there. So sometimes if you just rerun it, things work. And sometimes, I mean, currently I've tried my best to freeze the dependencies, but yeah, if sometimes it just doesn't work and you have to rerun things. Oh, it didn't run. Yeah, so here I'm running this code. It figured out, okay, model information, change param and plotter. So yeah, it figured out what the model pre-reproduction rate is, which is 2.1. It tripled it and yeah, ended up printing this. Also, I can show it from the example project also. So currently I only showed you on the predator prey model, but this can run on any radcat file. So for example, I'm running this on a pretty random model, which has like a random parameter with random like, what do you call it? Uh, State variables. And it's able to basically answer all the questions pretty much exactly the same way. So it's pretty model agnostic regardless of what we're doing. Yeah, plotter. Yeah, so it figures out what's really cool is again, like you don't necessarily also, oh, yeah, there you go. Also, it's an interactive chart, which is cool. You don't need to also write the variables in the exact like Python format. It actually you could have just done this, I think, and it should work if I'm not wrong. Like you can just say it in a natural language form and it understands what you're trying to say. Um, yeah, and it's taking about 20 seconds for some of the plotting functions at least. Yeah. You can make it faster by using GPT 3.5. Currently, GPT 4 is it's more likely that it gets things right, and that's why I'm using it for the live demo. I didn't want to mess it up, but if you use 3.5, it's 10x, like 10 times cheaper, and it's way faster. It's like within like 5 seconds, you'll have all of this. Stella had a question. I wonder though if you could build a builder agent, not for the purpose of one-on-one building the model, but rather synthesizing your data. Yeah, I think that's really interesting. And I think that's how I had initially used ChatGPT, where I was using it to brainstorm an idea about how to model itself. And maybe we can add that in the future as like the first section of just brainstorming with you and being able to chat and think through problems, maybe. But I think it comes down to what the community wants and what the community wants to like sees a value in. Do we want to take it to the last section?
Maybe I'll continue. I was just following the chat questions and I'd like to pick up some of them in the third part of this call.
Okay, I want to answer the one question though.
Okay.
What are the elements of the functionalities that you're most proud of? I think, I just love seeing agents talk to each other, being able to pass the right information to each other. It's just fascinating to see how they're able to sometimes they understand context, which is so strange. It's like, I haven't even given it all the context about the problem, and it understands that, hey, this is the right way in which I would do it. So seeing agents pass information in the right way, being able to have a thought, take actions on your code, observe results, and then understand what to do next. That's super fascinating. To me, also, yeah, being able to deploy other agents when they're required, like for plotting or for analysis. I think all of those things, like just the idea of agents talking to each other to solve problems and taking away all the headache of coding, I think is the coolest thing for me.
And I'd like to add here that I think we're striking a very good balance in taking the best of these two types of intelligence and combine it, meaning the human intelligence and the machine intelligence. Because we, as human beings, were not very good at, thinking in non-linear systems, thinking in a lot of different variants, keeping track of different settings and combine these. And this is something where agents are a great support. So it's just amazing to see them working through a simulations process and help us digesting the key insights and drawing key conclusions. Whereas I think that it's still, token, what are we designing here? We are trying to capture the purpose of a token network in an incentive design, in a token design. And this is still something humans should think about, should think through. It's a lot of stakeholder conversations. It's a lot of human thinking of how to make the most of it. And that's why I even think that this part of, the building a model of a system is a decision on what you are valuing, like what metrics are you observing, what is the optimal outcome. These are decisions. It's nothing that machines should and can take over at this point. And that's why I think, yes, it's cool to have in the future support even in building models. Still, there are a lot of strategical decisions to be made. And that's where I think humans have to be in the loop, and we should not, this is not about convenience. It's about this combination of the two types of brains. Okay.
Wait, I want to answer one question though,
yeah.
Because I think it's an important one. I think Jose asked this, that how does it help non-developers? I think the crucial bit is, okay, right now you're seeing it on a coding environment, and that's why maybe it's hard to imagine, but this is very easily portable to a front end, where a particular model developer or like a token engineer can build a model, give you just a website link, and you can ask your questions and work on a website where you don't have to install anything, you don't have to run Python. All of this can be automated via cadCAD GPT, and a front end is what would make it, like, it would be very obvious to everyone that you don't need a development background here. Yeah.
And maybe finally also this bundling tasks, if you prompt tasks in a particular order, Rohan.
Yeah, I did answer it. Yeah, so most of the times it answers it in the way that you asked it, like do this, do this, do this, but then sometimes it also makes strategic decisions, as we saw, if it knows that you can't do one task before the other. Yeah.
Okay. Let's talk in the final part about developing the token engineering sector, because our motivation was not only to try out LLMs, also to see how this could change and further develop the landscape of the TE tech stack. And you've seen that we have built it in a quite modular way. Again, as I told you beforehand, system modeling is the domain of token engineers, optimization techniques, and now this new layer of LLMs that make it easier and faster to run optimization techniques. Still all in the domain of a token engineer. So I guess one of the messages here is we don't think that these cadCAD GPT can and should replace a token engineer. However, we see typical challenges in token engineering projects. For example, stakeholder communications, because as a token engineer, you have to continuously talk to your stakeholders. It starts with what do we want to represent in our digital twin? What are we aiming for? What are we trying to find out? What metrics do reflect these goals do reflect these questions? And then you run simulations, you are drawing conclusions for yourself, and you have to discuss it with the stakeholders. And sometimes stakeholders don't really understand how much effort it takes to build an experiment, to run simulations, to optimize the results. And as soon as you come back with questions, of course, and that's good, they come up with new questions, and you want to find out answer the next question. What if? And these conversations and these iterations take time, and it's a challenge sometimes to handle the interaction with stakeholders, because they not always understand why it takes so long, why is this so expensive. So in the future, we hope to see that cadCAD GPT makes it possible and easier for stakeholders to run experiments themselves. And there is a trend that we are seeing in the space where token engineering service firms are building own tools that allow stakeholders to go over certain scenario designs. We also see it, for example, in risk dashboards that inform DAO decision makers on particular designs or at a current state, about the current state of the network. And this is all in the direction enable and empower stakeholders to dig through the systems and draw conclusions for decision making. Okay, so it will support the stakeholders' communications. Now, there's also a typical challenge for token engineers at the other end of the process when it comes to the system model. We've seen so many cases where token engineers try to build a model of a system and then chasing the developers about missing information. So what's the current implementation of the algorithm? Is there any additional component, any add-on? Aha, okay, this algorithm has been changed, all right. What's the implementation here? How can we get to the exact right, correct, up-to-date mechanism that we have to integrate in our system model? And there is today no natural standard workflow to get to this version controlled translation of smart contracts to Python system models. Now, what if it would be a common practice that projects and protocols provide this information as part of our agents framework's memory, or even as part of the components, so that it's way easier to build optimization techniques on top, the core domain of token engineers. And it would be less tiresome, less risky, much less mistakes and uncertainties. And in fact, this is what, for example, Token Spice was all about. So have this direct connection and process of, here's the smart contract, here are various versions of the system, here's the translation to the Python model representation, and here's additional information that LLM agents have access to make this whole process of token system optimization easier. Okay, now we have solved two challenges, or are about to solve two challenges: integrate the stakeholders in the process and integrate the ever-changing smart contract implementation to the process. Now, the long-term vision is, and again, this is not only an idea, it's what we already can see in DAOs, for example, that there are certain representatives of stakeholders with an assignment to take care of a particular optimization goal. One example is the stability facilitator and the MakerDAO ecosystem, with the mission to observe, monitor the optimization and oversee and steer the optimization of stability in this ecosystem. And this role needs tools, and token engineers can provide tools, certain optimization techniques, certain monitoring techniques, and LLMs can be a great supportive interface to make this task easier for all parties involved. This as a brief outlook of how LLM agents might be able to contribute to the further development of the sector. Now, finally, how can you be part of it? Our next steps are building expansions. So again, cadCAD GPT, the framework, the agents are open source. You can now fork it, start playing around with one of the example open source models that are available, cadCAD or RedCAD, or with your own models for your own project. And of course, the community, we invite everyone to be part of cadCAD GPT with adding new tools and memories, meaning we have here a list, and there's more in the repository. We have some immediate ideas on new tools that would be perfect to add. Also, optimizing short-term memory, make it most efficient while increasing the quality of the results is another topic. How to convert short-term memory to long-term memory. So where do we need the history of the conversation of agents in the actual long-term memory accessible in the simulation process? Version controlling of parameter settings and experiments so that you can compare results that you have created in the past. Also undoing tasks, quite a simple step, super useful that you can't do at the moment. And retrieval augmented generation for improving the planner agents planning abilities, and also exploring newer or alternatives LLMs. At the moment, we are using OpenAI. Just some of the expansions that we have in mind. And again, it's an open source project. Everybody's invited to take part. We are currently raising funds to also open up for bounties so that we can reward contributors. And ideally, but this is something midterm, we would love to see some kind of a marketplace where optimization techniques can be integrated into the toolkits and can be monetized. And this way spark off collaboration in the ecosystem, and an open source way to combine contributions from different domain experts. All right. This is the invitation to join the cadCAD GPT Discord. Here's the link. I'll also drop it in the chat as well. And in addition to that, of course, we are very interested to see projects and teams testing it out for their token engineering project and needs. So in case you're currently working on a token design or a token design optimization, please reach out to us. We would be excited to support you in testing cadCAD GPT and share the learnings in the community as well. All right, that's it.
So should we share the GitHub link? Is that?
Oh yes, sure.
Yeah. Okay, it's on the chat. Feel free to open it, play around, or download it the way you want to. Yeah.
And again, you'll meet us in the Discord. Feel free to drop any questions you might have. Okay, that's it from our side for today. Excited to see cadCAD GPT develop. Thank you for joining us today. And let's make token engineering stronger and stronger together. Talk soon. Thank you.
Thank you, everyone. Yeah.